Hello, welcome everyone. Let's share the link. Hello friends and welcome. Hello, welcome friends. I will start in not less than 3 minutes. So meanwhile, watch the problems there and start solving so that I will join you along. For now, I'm sharing the live. So I'll join you in 1 second. So please make sure you're solving the problems there. Is that okay? Good evening, everyone. Okay, let's begin to solve the problems we're having over there. If you can hear me, just type hi, so I will know you can hear me clearly. If you can hear me from your location, just indicate with hi. All right. So welcome friends, we want to solve a lot of problems, and if you look closely, this is the most recent year, which is 2020 against 2021. So our target is not really to pursue all the questions from the start to the finish, but we want to predict the ones you should be expecting, the kind of question they can't do without. That's one of the reasons for this tutorial. So, but then let's play with the basic one we are seeing right away. The first question there says that, I just hope you can see clearly, or let me turn the camera like this. Is it more clear right now? Can we all see? So make sure you're with your writing materials, because we're going to assume that we're in the exam hall and we're given this problem to solve. So what can we do about it? Because when you try and you're unable to get it correctly, that's why I'm here. But if you're able to get it correctly, it means you'll be able to check your ability. All right, so the first question there says, if a particle moves along a curve, and then you're having arrow equal to t squared plus t I plus 3i minus 2, or 3t minus 2j plus 2t cubed minus 4t squared k. So we're asked to calculate the magnitude of acceleration at t equal to 2 seconds. And here we have the options. So pause the video for 1 second and just attempt that problem. So while you are attempting that problem, I'm going to do it alongside with you, because that's a technical problem. Okay, someone said it's better like this. Okay, if it is better like this, then let's leave it this way. Okay, so from that problem, we have that arrow is equal to t squared plus t. That's the first one we're having here. Okay, what are you not seeing? You say the words or what? Can you see it better now? All right, so the first problem, we're interpreting it. We have r equal to t squared. I'm rewriting it now so that I can see it better. I plus, we have 3t minus 2j, and then we have also plus 2t to the power of 3 minus 4t squared. Then we have k. Right, that's the equation. So now, what we are asked to find is, we have to calculate the magnitude of acceleration at t equal to 2 seconds. So we're asked to calculate the magnitude of acceleration. The magnitude of acceleration at t equal to 2 seconds. This is what we're asked to do. Are we following? Are we together? Please, you need to be responding on the comment section so that I will know if you're following me. All right, because I need to carry everyone along. So this arrow here is representing the distance. In some cases, they might want to use d, they might use x. This is representing distance. And for you to get the magnitude of the acceleration, then it means that you need to do some sort of differentiation. And I know that in your mathematics, you all did not do, you didn't offer differentiation, calculus this semester. And then you also did not do integration this semester. So that means I will need to break it, because there are a lot of your questions that may want you to use the differentiation and integration. And it is also there in your textbook, your physics 111. So we will need to apply differential calculus in solving this problem. So let's do that quickly. Now, the first thing I will need to do is to make sure that I take the derivative of this. How do I take the derivative of this? I will just write the arrow with respect to t. Why am I doing it with respect to t? Because if you check, we're having t on this right hand side. So I'm taking the derivative of this arrow with respect to t. All right? So that means that I'm going to differentiate each of these items here. Differentiation of t squared is what? Who can tell us? What is the differentiation of t squared? If you're good in differentiation. While you're telling me, let me write down the formula for differentiation. We have nx to the power of n minus 1. This is the formula of differentiation. So if you're asked to differentiate t squared, yes, beautiful. Some persons are getting the answer already, 2t. So the power here is 2. So anywhere you see n, you just plug in 2, replace this t for x. So you just have 2t, 2 minus 1. 2 minus 1 is 1. So here we have 2t. Congratulations, you guys are very good. So that means the differentiation of t squared is what? 2t plus. So what is the differentiation of t? Without wasting time, we know is 1, right? I suppose that's what you have. Exactly. So, and then we have this I attached to it. Already, you know what is unit vector, ijk. So when I'm having I, you should not feel maybe I'm having different concepts altogether. Now, let's move to this second one. Differentiation of 3t is what? Is 3, right? Since differentiation of t is 1, differentiation of 3t will be 3 times 1, and that will be 3. Good. So we have just 3. Remember, here is plus. Differentiation of a constant, which is 2, is 0. All right? Here becomes 0. So what we have left is just 3 and this j. I hope there is no question here. Is there any confusion? Then for this last one, we have plus. I've messed up this space. So let's continue with this part. What is the differentiation of 2t cubed? It's just for you to use this 3 to multiply by 2. That's the short method. 3 times 2, that will give us 6. And then 3 minus 1, that will be 2. So we should be having 6t to the power of 2 to be the differentiation of this. All right, I'm seeing some person dropping the answers already in the comment section. That's beautiful. So we have the differentiation of 3t squared cubed to be 6t squared. And minus, what is the differentiation of 4t squared? What is the differentiation of 4t to the power of 2? Beautiful, beautiful, beautiful. So the result of that is 8t. And then we have this k attached to it. All right, so this is the point we've gotten to. And then if you know or remember your definition of velocity, you remember that velocity is a change in displacement with respect to time. Or you say velocity is the rate of change of distance with time. So that means this particular one is literally telling us that this is the same thing as velocity. Is that true? So you know, if we're able to get velocity, it's simple that we can be able to get acceleration. And for us to get acceleration, we take the second derivative. What I mean by second derivative is to add 2 like this to arrow and then the t squared. This is talking about the second derivative, meaning that you should differentiate this again. And if you're taking the second derivative, it means you're talking about acceleration, because acceleration is talking about the change in velocity. Are we following? If you don't understand this method, I'll have to use another method for you to flow with me. Do you understand it like this, or should I use another method? And please, if you're watching us, please make sure you like this video. If you've not subscribed to the channel, please hit the subscribe button. Okay, someone said I should go on, so let's proceed. This means that we should differentiate again. Someone said I should use another method. Another method means, since this one is for velocity, it means you should just differentiate. Acceleration is the change in velocity with respect to time. This man means that you should differentiate this one again. Since this one is for velocity, then this thing means that you should differentiate this again. This one also means that you should differentiate this again because of this one. So either of them, any one that you can flow with, any one of them that you can flow with is the same thing. Two of them means you should differentiate again, and two of them means acceleration. I hope that is clear. Is it clear? So if it is clear, then let's differentiate now. Let's start differentiating right away. Differentiation of 2t is what? Differentiation of 2t is what? Is 2. Then differentiation of 1 is 0. So what we have is 2 times I. So we have 2i like this. All right? We are done with that. Let's move down to this one. Differentiation of 3 is 0. So there's no point we having something like 0j. But if you just want to leave it like this, it's still fine. But left for me alone, I wouldn't want to add this because nothing is nothing. All right? All right. So if that is clear, then we have plus. This third part, we have to differentiate this. And differentiation of 6t to the power of 2 is 12t. And if it is 12t, so we have 12t minus differentiation of 8t is just 8. And then we have k attached to it. I hope this is clear. Good. Now that we've gotten to this particular point, it means that we need to take this is what we are asked to look for. The magnitude of the acceleration at t equal to 2 seconds. That's essentially what you're looking for. So since we have differentiated the position vector twice, and then at t seconds, what we need to do is to say that, let's remove this since we have used this first one. We say that a will be equal to, so the next thing we'll have here is to say 2i plus, remember that we've crossed this one out. Anywhere you see, or let's put at 2 seconds, at t equal to 2 seconds. This, it came with equation, all right? That's what we are asked to look for. So what we need to do, anywhere you see t, you plug in your 2. So we have here to be 12 times 2 minus 8, then k. All right? So we have a to be equal to 2i plus, what is this expression here? 12 times 2. Please, you make sure you have your calculator close to you so that you make the process fast. You know, we are still on number 1 and we don't intend to waste this time like this. So I'll be skipping question, the one that has to do with differentiation that I know that they will repeat. Those are the one I will pay more attention, but I will do a lot this night. Okay, so what is the total result we're having? 16. Yeah, that's beautiful. This is 24 minus 8. We have 16k. And if you're looking for magnitude of any vector, say vector A, it means that if you're looking for magnitude of vector A, of course, by now you should be familiar with the formula, the square root of what? 2 squared plus 16 squared. Are you guys familiar with this? Keep in mind that you don't need to bring in the position, the unit vector attached to it. Are you guys familiar with this? If you're familiar with that, so let's finish up. We know that 2 squared is 4, plus somebody should punch 16 by 16 square. What is the result? Let's make it faster. Please make sure your calculator is with you, and if you're just joining, please like this video and subscribe to my channel. That will encourage me. Just hit the like button. It's not a difficult thing to do, and then the subscribe button. It doesn't cost you much. Since you're here already, just hit the like button and make sure you drop good comment. Okay, somebody has dropped an answer. Say 2. Verify if it is 256. If it is 256, that's okay. Then now we have to add 4 plus 256, and that will give us 260. Please, somebody should check the square root of 260. Somebody should check the square root of 260. Quickly. And then we don't want our, we don't want our answer in sodic form. Reason being that our option here is not in sodic form. Look at it. Option A is 9.9 meter per second squared. Option B is 15.3 meter per second square. Option C is 16.12 meter per second square. Option D is 21.33 meter per second square. So which of them do you think is the answer after you would have checked the square root of 260? What's the answer, please? Let's do it together, gentlemen. Okay, I'm seeing 16.12 meter per second square, because acceleration is a meter per second square, the SI units. Oh, right, that's option C. Let's check option C. Beautiful. That means we are good. We are good to go. Congratulations, guys. So let's move on quickly because we do not have much time. Let's see into the second problem. I told you I'll be selecting question at random. Anyone that looks somehow tricky is the one I want to solve. All right. So this is something you can just look and then solve. This number 2 is very simple. Let's do it together. Given that, are we seeing what I'm reading? Or do I need to bring the camera closer? Oh, thank you very much. Those of you who are hitting the like button and subscribing to my channel, thank you very much. I really do appreciate you. And if you have your colleagues who are not here and you feel you want to share this live, please share it to them. They need to come and learn with you. A lot of people fail this physics 111 and they are supposed to be writing with you tomorrow. So it is very okay if you invite your friends. Just share the live video so that they will join us here and learn with us. Thank you very much as you're hitting the like button and subscribing. All right, so what do you think is the answer to this second problem? And the problem say that given that the mass of a moving object is 9 kilogram. In my physics, I usually teach students to make sure you take down the parameters given in the equation. So now you've seen mass to be 9 kg. Please take down the mass to be 9 kg. All right, and moving with a velocity of v equal to, that's the velocity. So literally we're having the mass, our mass is equal to 9 kg, and then our velocity, someone is, okay, are you sending the answer to the just concluded one or the one we're about to solve? So let's do it together. If you've solved it already, that's okay. So here we have the velocity to be 2i, 5j, and 4k. So we have 2i minus 5j minus 4k. Okay, what's the instruction? You asked what is the momentum? All right, that's very beautiful. Look at the option. Look at the shape of the option. It comes in the form of the unit vector ijk. All right, so you're asked to calculate momentum. You know momentum, what's the formula? Everybody, what is the formula of momentum? Tell me. I want to be sure you've prepared. You're well prepared in this exam for these exams. And you must match it tomorrow. Believe me. So what's the formula for momentum? Oh, yeah, beautiful. I've seen one person saying mass times velocity. That's beautiful. So if momentum is equal to mass times velocity, and our mass is given as 9, all right? Velocity is given as this unit vector 2i in the I direction. We have this j and this to be 4k. So you see that the math is simple already. So 9 will distribute. If 9 multiplied by 2, what do we have? That's 18i minus, if 9 multiplies by 5, let's do that quickly. 9 by 5, should that be 45 or thereabouts? What is 9 by 5? Is that 45 or 40? Somebody should help us right here. I think that should be 45. Let's put it down. That's beautiful. Minus, somebody should tell us 9 times 4. 9 times 4, 9 times 4, 9 times 4. What do we have? Okay, is that 36? 36k. So that's the answer. This is the answer. Which one is 40? Is it? Okay, 36k. Okay. Now this is the answer. Let's check our option quickly. Option A, we are having 1, 0.5. This is out of the box. Option B, we're having 36, 27. This is out of the box. Oh, we're having 18, 27. You can see the confusion. I think we're having 18. We're having 36 also, but here is 45. So let's keep moving. Okay, we're having this. We're having 24. Okay, and then we're having this. So which is the option? D is the option. Beautiful. So the option is D. Even though if you notice, they made mistake. They are having positive sign here. Meanwhile, the equation came with negative sign. And then, but then as much as D is capturing all the answers, then we are good to go. All right. Okay, so let's move forward. The number 3. Number 3 says, number 3, the acceleration of a particle. Are we here? Can we proceed? Thank you for joining. Thank you for joining. Thank you for joining. If you're just joining, please hit the like button. Help us grow the channel. Hit the like button. That will grow and increase the algorithm of this channel. And also, please like the video. Subscribe. That will go. Can we proceed? All right. Beautiful. Let's look into this number 3 question. The acceleration of a particle is given by, look at it, write this down. Let's use it to solve problem. Is given by, write it down please, because I'm writing it down right here. Is given by A into T equal to 3 meter per second to the power of 4, then T squared. So they say that if the particle is at rest at T equal to 0, all right, listen now. If the particle is at rest, if a particle is at rest, it means the time is 0. Then they say you should find the velocity of the particle at T equal to, you're finding the velocity at T equal to 2 seconds. All right, these are the options. So let's solve. This is the equation. I've brought out the parameter. Look at them. I hope you can see clearly. So I want to start solving. This looks a bit very tricky. If you didn't pay attention, you fail it. You can now see the reason why they say physics question is very simple, yet people are failing, because watch the way I'm going to solve this. Your mindset may not even go towards that direction, but obviously it's what we're going to do. I'm sorry, somebody's saying the network was bad. I don't know if it's coming from my end, but I'm sorry. There's nothing I can do, obviously, but let's just manage, please. Let's just manage. And if you're just joining, please like the video and subscribe to my channel. Okay, let's solve this problem right away. So what do we need to do? The first thing we need to do, since we're asked to find velocity, meanwhile what we are given here is acceleration. Acceleration equal to this, and we're asked to find the velocity. It means that we need to do something. We know that from the definition of acceleration, acceleration is equal to the change in velocity with respect to time. Is that true? So since it is this, and then it needs to find the velocity, we need to cross multiply. Then we just cross multiply this dt and this a. So we now have that dv equal to a dt. I hope you're getting it. I just cross multiply this and we're having this. For me to get this acceleration to stand alone, I'll take the integral of both sides of the equation. This elongated s represents integration. So, but then whenever integration meets with differentiation, they cancel out. So v now will be equal to, I will have to take the integral of this a. And what is a? I will take the integral of this a with respect to t. And d having these values here. Or what you're seeing here. So how do we take the integral of these 3? The integral of these 3, we're having 3t squared. If you multiply this 3 by t to the power of 2, this is just a unit you're having here. So that means I have to integrate, I'm integrating 3t squared. So on integrating, I will have 3t to the power of 2 plus 1. Keep in mind that the formula for integration is x to the power of n plus 1 all over n plus 1 plus constant c. This is the formula for integration. So any power you have, you add it with 1, and anything you have up, you photocopy it and paste downwards. All right? So this is it. The power I have here is 2. I will add the 2 to 1. That's how I'm having 2 plus 1. I will still divide it by 2 plus 1. Is that okay? Are we following? Is that okay? So what will this give us? This will give us 3t to the power of 3 over 3. And of course, 3 will cancel 3. So we have v to be equal to t to the power of 3. Then keep in mind that you ask at t equal to 2 seconds. That means anywhere you see, is that the answer you are writing already? Some say 45, some say 36. Okay, let's watch the end. At t equal to 2, v will be equal to 2 to the power of 3. So v now will be equal to 8 meters per second. And this is the answer. Now you can see the difference between your answer and what you are expected to have. So let's check the option if we have the answer there. Okay, we have first one to be 5.0 meter per second, 4.0, 8.0, and 12. So what is the option? What is the option, gentlemen? You're seeing that option there to be C. Please take note of it. Take note of it. That's good. All right, let's move on to the next question. Please make sure you take care of these questions and then take note of them. If you see something, of course, this one that has to do with integration and differentiation, they will bring a lot of them. I will skip this when I solve to our next thing. I'll start skipping to those ones that are kind of technical, so that when they bring them tomorrow, you can be able to solve them. Okay? If you're just joining, please like the video and subscribe to my channel. Thank you very much, and share the video, so that share the live rather, so that others will join you. Look at question 4. Everyone here can solve it. I'm very sure that everyone here can solve this question 4. I trust you so much, and I believe you can do it. Okay, that's okay. Someone is saying after the video I should share the question so that you guys can attempt. It's okay, but you can be snapping the parts you've captured here too, in case I'm not able to do that if I didn't remember, but I'm sure going to do that. But if you have me on WhatsApp, you can still relate with me after the live chart we're having. Okay, here is the question we are having, number 4. The maximum horizontal distance for a projectile is given as. This is just a formula. Okay, please take note of this. They said the maximum horizontal distance. People will mistake this one for height. It's not height. Horizontal, this is talking about the range. Is that true? The maximum horizontal distance, that's talking about the range for a projectile is given as. Okay, let's look at the formulas. This is for height, okay. Okay, this is for range. And this is not a formula for range. Hope you know. This is not the formula for range. Do I need to do a revision on that? For range, for projectile motion, the time is to reach the maximum height is u sine theta over g. Is that true? But for the time to reach the complete full oscillation, what do we call it? For the object to move from the point of projectile to the other point, I think that is when you're adding 2, the total time taken. Yeah, 2u sine theta over g. That's for time. Then if you're talking about the height, the maximum height is about u squared sine squared theta over 2g. Then if you talk about the height, when this angle is given as 90 degrees, then this height will be u squared over 2g. I'm just stating the formulas we have in projectile motion, the basic one. Then the maximum range is u squared sine 2 theta over g. Am I correct? Am I correct? If you say I am correct with this formula for range. Oh, thank you very much, Gabriel. The Pablo is here. Thank you very much. Please, let's keep sharing this live video because there are a lot of persons that may want to be here, but they are not aware of this. Okay, then let's see the option if this formula will correspond to what we're looking for. Then you can see that the option, this is option C. It doesn't give us what we want. D. I think D is the answer because we're having this V naught square is talking about initial velocity. They have different formats they use in representing it. Sine 2 alpha, you can use alpha or theta as the case may be, all over G. I think this D is the option. Oh yeah, I think some of you are subscribing to my answer. Okay, that is fine. Can we solve the next question, please? Let's keep moving forward. We're having next question to be number 5. Number 5, okay, let's take down the question. Can someone solve number 5 quickly? Let me see how, because this number 5 looks like what we just finished solving. Here says a particle moves in the horizontal direction from 0 with an initial velocity of, please take note of it, with an initial velocity. Or somebody is saying, but the same thing with C. Let's check. The previous, you're talking about number 4. Says the same thing with C. Let's see what C has. C is talking about height. Look at it. C is having h. So there's no way it should be the same thing now, right? We are looking for arrow, which is the range. It's not h. So that's what you need to look carefully. Don't look at the formula only. Look at the left-hand side. What they have there. If it tallies. Is that clear? All right. So let's continue what we are doing. So we have the initial velocity of 6 meters per second. If the acceleration at time t second, if the acceleration is given by a equal to 2t plus 1, find the velocity of the particle after 6 seconds. Have you taken note of everything I've dictated? Because we want to start solving. As I'm reading them through, I'm also taking down the parameters so that we can use it to solve problem. And from the parameter, we have initial velocity to be 6 meters per second. Is that correct? Initial velocity is 6 meters per second. And we have acceleration to be 2t plus 1. Acceleration is 2t plus 1. Or somebody is still talking about the range? Yes, the range could be that's u squared all over g, depending now if the angle associated with it. This one we are talking about the maximum range. All right, so let's proceed, please. So we are asked to find the velocity, right? We are talking about this question 5. You are asked to find the velocity of the particle after 6 seconds. You're asked to find the velocity. Okay, you're asked to find, oh, this is 2t plus 1. Let me erase this. We have a to be equal to 2t plus 1. You're asked to find the velocity at what? You're asked to find the velocity after 6 seconds, okay? After 6 seconds. So the velocity after 6 seconds. So we've done something related to this. Someone should be able to fix this for us. But let's do it together. We know that acceleration is the change in velocity with respect to time. When you see dv over dt, it's talking about the derivative of the velocity with respect to time. Is that clear? And again, by the time you cross multiply this dt with a, you have that dv is equal to a dt. So take the integral of dv, apply integral to both sides of the equation, so that we've done something similar to this. When integration meets with differentiation, they cancel out, so v will be left. Now we need to integrate a. What is a? A is 2t plus 1. So integration of 2t, watch, this is not differentiation. Integration of 2t. That means we are literally having integral of 2t plus 1 with respect to dt. I'm writing it out. This is what we're having. So that means we need to integrate this one with respect to t, and also integrate 1 with respect to t. That will now give us integration of 2t will give us 2t squared, because it's going to be 1 plus 1 all over 2, plus integration of 1 is just with respect to t is just t. I hope you are aware of it. All right, if you are able to do this, remember that you are asked to do it at t equal to 6, after t equal to 6 seconds. So you have v to be equal to, remember that this 2 will cancel out with this 2. So we're having t squared plus t. So that means after 6 seconds, we have that this becomes 6 squared. Please bring your calculator out. Plus 6. I'm aware that 6 squared is 36. Plus 6. What will be the result to this? Someone should talk to me. I'm saying 36. Are you sure it's 36? Are you sure it's 36? I'm having 42 meters per second. Okay, let's confirm if it is 42. I just need you to see why we need to be careful while solving problem. I think we're having 23 here. 20, 50, 42. You see it? So the option is what? If you're enjoying this, please like the video. If you're enjoying this, please like the video, share and comment. And make sure you subscribe to my channel. All right, I hope you're making good progress. These are the basic one I needed to put you through so that you'll be able to know these stuffs very well. Okay, let's see number 6. Can we see number 6? Can we see number 6? Who can tell us the answer for number 6? Number 6 says, which of the following is not true of the dimension of a physical quantity? Before you can be able to answer this, you must know what dimension is all about and what they use dimension for. But it's simple. Let's read through the options. We can get the answer immediately. Which of the following is not true of the dimension of a physical quantity? Okay, guys, let's fix the answer right now. So number 1, they said to check the homogeneity of a physical equation. That is correct. 2, to determine the uniformity of a physical equation. Have you considered that? This one, to check if it is a fundamental or derived quantity. Have you considered that? Number D, to determine the exact form of a physical equation. So what do you think is the option? What do you think is the option? Yes, what do you think is the option? Are we together? Okay, I'm seeing some people having B, some people are having C. So which one is correct? Let's look at the B and the C we are looking after. Number 6, the B says to determine the uniformity of a physical equation, and then C says to check if it is a fundamental or derived quantity. This is what I'm even thinking that it should not be here. The number C, we don't use dimension to check if it is fundamental quantity or derived quantity. We know what fundamental quantity are all about. The quantity that does not depend on any other quantity, which include mass. We have the length, we have the time, we have the amount of substance, which is measured in mole, we have the luminous intensity in candela, we have the temperature in Kelvin, and those are the fundamental quantities. We still know the derived quantity with the velocity, acceleration, force, and all that. So it's not basically to check if it is a fundamental quantity or derived. We know what they are. So it's C. The answer is C. C is not supposed to be, because remember the question says that which of the following is not true of the dimension of a physical quantity. It's not to check if it is a fundamental or derived quantity. So let's take C as the answer. If you feel B is also the answer, or maybe you're okay with B, that should be your choice. At least it's not calculation. I'm interested in calculation right now. Number 7 says, which of the following is not a fundamental SI unit? I think you should know this. Which of the following is not a fundamental SI unit? I think I've mentioned this right now. Is meter a fundamental quantity? Ampere, is it fundamental quantity? Mole, is it fundamental quantity? Newton, which is the option? Please make sure you get this one correctly. Make sure this one is correct. Make sure you get this correctly. Some people are saying B, some people are saying C, some people are saying D. How could you say ampere? Ampere, current, is also a fundamental quantity. The basic fundamental quantity are mass, length, and time. But current is also a fundamental quantity, and current is measured in ampere. Am I making sense? So current is a fundamental quantity. Mole, amount of substance is measured in mole, and that is a fundamental quantity also. I just mentioned that. This is a fundamental quantity. Amount of substance is measured in mole. You should be considering Newton, because force is measured in Newton, and force is a derived quantity. Are we making sense? Are you getting sense from what I'm saying? The option is D. Ladies and gentlemen, let's have D to be our option. Yes, D is the option. Okay, let's leave that one. I like that. Somebody said normal is D. That's okay. All right, let's proceed, please. We have number 7 to be, which of the following? Okay, we've talked about number 7. Number 8, what is the force exerted on a human by full moon directly overhead an adult of mass about 75.5 kg at a distance of 3.75 times 10 to the power of 5 kilometers away? All right, this question looks a bit tricky, but please, let's fetch out these parameters. With this parameter, we can be able to get what they want us to do. They say, what is the force? Okay, so means we are looking for force. That's all right. What is the force exerted on a human by a full moon? Okay, directly overhead an adult of mass about 75.5 kg at a distance of this kilometer away. Okay, well, some persons have started giving the answers already. Have you solved it? Some persons have. Okay, these are the options. All right, so let's interpret that quickly. I hope you're with your calculator. Let's do this analysis. The full moon exerts 2.4 times 10 to the power of minus 3 Newton on human. This is normal. You should just take note of this. On the human, this is the particular force a full moon exerts on human. All right, then the mass of the human is given from the question as 75.5 kg. Also, the distance from moon to the man, maybe you can use D or you can use arrow, is given as 3.75 times 10 to the power of 5 kilometer. Abi, is it kilometer? Let me cross check that. Is it kilometer I saw? Okay, distance, kilometer away. All right, so for this kilometer, I can still make it to be in meters. And if you want to make this to be in meters, it means you should just have it to be 3.75 times. This kilo is 10 to the power of 3. 10 to the power of 3, if you do your indices, 10, 10, you just pick one of them. 5 plus 3, that will be 8. And this will be in meters. I hope you grab. All right, the next thing is the gravitational constant. The gravitational constant is capital letter G equal to 6.67. Of course, you should know this. Usually come in your exam. What is the gravitational constant? Some people usually have it to be plus 11. It's not plus 11, no. Is, and then this unit, you need to pay attention to it too. Then finally, if you didn't bring these parameters, it will give you an issue for you to be able to solve. Acceleration due to gravity. Which is G is equal to 9.81 meter per second square. So now the force exerted by the moon on the human will be F equal to G. Have you seen this formula before? Mn all over, you can have this to be r squared, but in this case I use D. D and r, they are still talking about distance. You have to square it. So this means you have to bring out all the constants you have, multiply them and divide it. That will give you the answer. I don't know if you have your calculator. That's what you should do by yourself. So that we'll move to the next question. Like this G, we have it as 6.67 times 10 to the power of minus 11. You multiply it by mass, which is, we have the mass to be 75.5. The mass of the moon is the second one, which is, where is that value? The mass we have on the moon, the full moon exerts 2.7 Newton on the human, and the mass of the human is 75. We've written this. The distance from the moon, the man of this, is this one. And then we have the gravitational constant to be this, and the acceleration due to gravity. Okay, we have this to be the masses. The second mass is the mass of the moon, and we've not captured that particular one. And then you need that so that by the time you divide by, or somebody is complaining of network. Is it coming from my end, or is the network coming from my end? Hello everyone, can you hear me? Okay, somebody is complaining of network, so I thought it's ceasing because I've not been seeing the reaction from you. We're having 80 persons viewing the live video. So if you're just joining, please like this video so that we'll make good progress as we are solving along. All right, so we have the distance. Okay, we have this moon, that of the moon to be 2.4 times 10 to the power of minus 3. And then if you divide all through by distance, the distance is this one, which is 3.75 times 10 to the power of 8, and you square it. Whatever it gives you, that will be the answer. I do not have calculator right here. That's why I'm depending on you for me to be able to make good progress. All right, this is filled up. Let's continue with the next phase. So by the time you do your punching, you check, you go through the answer if it gives any of this option you're having here. But in most cases, you should be looking towards A. It almost looks like A will be the answer depending on whether you punch your work correctly. All right? Okay. Because of time, I don't want you people to be leaving me on this particular point. So let me do some sort of skipping. Let's move down to question 51, because I saw something tricky on 51. These things are much, so that I will just show you the basic one that you should be familiar with in case it comes in your exams. because I'm seeing that some persons are going. We're having more than 90 persons and they are going gradually. So I don't want you to leave me here. So let's be doing the ones that are much technical, that when you see it in exam, you want to dodge. But I don't want you to dodge it. So let's do it. Look at 51. Is this something you can do? 51 says the angular displacement of a rigid body is given by the equation. Look at it. You have to find the angular. Oh, somebody says it's data that is making them leave. But I informed you guys that we'll be having the class by 10 o'clock. If I were you, even if it is 1,000 subscription, just to make sure you don't come back to write physics with the next set. I want to do it, honestly. But I just hope you can be able to cope with the time derivative. All right, so we are working on 51, and I said that the angular displacement of a rigid body is given by the equation. Let me write down that equation. We have theta equal to 4t to the power of 3 plus 3t squared plus 5. All right, find its angular acceleration. So you have to look for angular acceleration after 3 seconds. That's interesting, right? So these are the basic stuff I jotted down from the equation. Okay, so let's go straight to the solution. This is the angular displacement and is given by this. All right. I'm sorry, guys. Those who were not able to get much data, I'm sorry. I'm sorry. That's why I'm trying to boycott some process so that I can be able to end the live and then you continue from where I stop. I just need to tackle the one that looks a bit technical. All right. So maybe in subsequent time, we'll be fixing the class at night so that people can be able to cope. Maybe in your 200 level, when I will be helping you with your mathematical method and some of your engineering, physics, and maths. All right, so let's proceed. So we have that this angular displacement is this. You're asked to find the angular acceleration. But before you get angular acceleration, you must have your angular velocity. Have you heard about omega? This omega, like this. This is angular velocity, omega. You know about it, right? It talks about the angle swept. If you're talking about circular motion, which is, okay, let's leave the angle swept. Let's use the usual one that you know. The change in the angular displacement with respect to time. Okay? So that's what it means. I'm just taking it step after step so that you don't get confused. If not, in an ideal way, I'm just taking the differential expression of this twice. If I differentiate this 2 times, that will be it. But just take it bit by bit. All right. To differentiate this, what is the answer? Who is going with me? All right, differentiation of 4t cubed is 12t squared plus differentiation of 3t squared, that will be 6t. This is 0. All right, differentiation of a constant 5 is 0, so we're done with that. So the next thing we need to do for this angular acceleration is to differentiate this omega, which is angular velocity, with respect to time. That means we are differentiating this one again. I'm just breaking it down. If you differentiate this, you have 24t plus Division of 60 will be 6. So at t equal to 3 seconds, what do we do? Angular acceleration will be equal to 24 into 3 plus 6. Ladies and gentlemen, can you point your calculator and tell me exactly what you feel the answer will be? So like we check it, so we check the option and then get the option or the best answer that fits this one. Yes, who is on the calculator? Okay, I'm saying 78. Let me fix 78 first. Okay, let me say a smart person who will tell me the SI unit without we checking the option. SI unit, SI unit, SI units, SI units. Ladies and gentlemen, SI units. SI units, SI units. Are we together? Beautiful. I'm seeing someone saying radian per second square. That's beautiful. No, it's not radian per second, because we are talking about acceleration, angular acceleration, not angular velocity. In this angular velocity, we have radian per second. Angular acceleration, we have radian per second square. Not meter per second. We are talking about circular motion. So not linear motion. If it is linear motion, you have meter per second for velocity, meter per second square for acceleration. Oh, straight away, let's check the option. Let's check the option. What number was that? 51. We have 42 radian per second square. We have 36 radian per second square. We have 72 radian per second square. And we have 78 radian per second square. So the option is what? Oh, somebody's asking why radian. Is because when you're talking about angular, any motion, any particular object in rotational motion, whether it's circular motion or rotational motion, the unit is not measured in meters. In place of meters, we use radian. All right. So that's why we're having radian per meter square, because we are talking about angular. Does that answer you, Mr. Martins? Is it clear? If it is clear, what is your option? What's the best option? Beautiful. Somebody has posted what I was looking for. The mass of the moon, 7.34 times 10 to the power of. So if you plug that in, okay, maybe it's based on the options, because there are couples of options I saw that did not give exactly what we solved. That doesn't mean we solved it wrongly. No, we did the right solution, but sometimes the options is not captured. But as much as you know what you're doing, that's fine. So okay, we have the option to be D. So congratulations, guys. Let's look at 62. Somebody should solve 62 right away. No, before 62, let's do 52. 52, let's solve question 52. What's 52? I think so many of you know about this. You know about dimensional analysis. Dimensional analysis. Okay, let's read out the question. If T is equal to K, this is rho for density to the power of X. We have this arrow to the power of Y. And we have this that looks like gamma, which is for surface tension, raised to the power of Z. Now we are asked to represent the period T of a vibration of a liquid surface drop, which depends on the density, this radius arrow, and surface tension, this, of the liquid. What is the value of XYZ? That's what we want to work on right now. Are we here? Can we do that? Is this something we can fix? Can I do that with you? If it is a yes, then let's do that straight away. The formula given to us is T equal to K. We have this to be rho to the power of X and rho to the power of Y. And then we have this one that looks like gamma to the power of Z. Okay, thank you. Some person said I can proceed. Yeah, I'm already on it. All right, if you do not know dimension of some physical quantity, then you're in trouble right here. So what you're asked to find is X, Y, and Z. How can we find X, Y, and Z? Remember that this K is constant. And because it is constant, it has no dimension. So we call it dimensionless quantity. So, but then they have told us that this sign is for density. And what is the dimension for density? We know that density is mass over volume, right? So what is the dimension? No, you need to know. Or somebody's asking, how do we get the mass of the moon? There are some certain things that is meant to be, is derivable though, but then if you Google it, you get the mass of the moon is there, is constant. The mass of the moon is constant, is derivable. But in your level, you could just Google the mass of the moon and then have that value, substitute it in place of that place I wrote 2.4 times 10 to the power of minus 3, because that is for force. All right, is that clear? Okay, somebody is dropping dimension. That's okay. So since mass is capital letter M, velocity is LT to the power of minus 1, then the dimension will be M L, am I correct? T to power 1. Let's confirm that. Velocity is distance over time. Confirm if this is correct. That's what we're working on. Velocity is distance over time. Velocity is distance over time. Velocity is distance over time, which is LT minus 1. Are we there? Is it correct? Oh, sorry, volume. We are talking about volume, not velocity. Mass over volume. And volume is L to the power of 3. Volume is L to the power. Please, these people who are still bringing question, you're distracting me. I was looking at what you're saying, and I did not know what I was writing. We are done with the issue of moon. I told you that you should check the mass of the moon. You can Google it and then have the value, substitute it into that formula. That formula that I gave you that has F equal to capital letter G, that big G for gravitational constant, and then 2m. One of the m is mass of the moon, the other one is the mass given, all over rho squared. That's the formula for gravitational field. When you're stating the law, just like electric field, gravitational law, like Coulomb's law, the force of attraction between two masses is directly proportional to the product of the masses and inversely proportional to the distance that separate them. That's the formula. You substitute everything inside. Let's close the chapter of the moon and focus on this, please, because that is confusing me. All right. Somebody is asking, how do we know when to integrate or differentiate? It just all depending, like if you check the previous problem I've solved, it's just depending on what is given to you. If you're looking for velocity and you're having something like dv equal to something else, and you're looking for velocity, for you to see differentiation, you need integration to cancel this differentiation. All right. Otherwise, it depends on the nature of the question though. So mass over volume is length times length times length, or length times breadth times height, which is L to the power of 3. So the dimension will be ml to the power of 3. Are we correct? That's for density. Is that correct? Minus 3 here. All right. ml to the power of minus 3. So that's for density. I'm saying no. Am I making me see? ml to the power of minus 3. That is the dimension for density. Okay. It's mass over volume, not velocity. Yeah. So the next one we have is arrow. Arrow is for distance or for radius. As much as anything measured in meters, the dimension is L. All right. As much as it is measured in meters, the dimension is L. That's for radius. And what is surface tension? This is for surface tension. The formula is force over length. Surface tension is that makes the surface of a liquid act like an elastic skin. That's the reason why this pond skater can walk on the surface of the water. See mosquito walk on the surface of the water. Last week I walked on the surface of the water. Yes, because of surface tension. I study physics, you see. And if you read through the Bible too, was it Peter? He walked on the surface of the water. Jesus Christ also walked on the. They were physicists. They understood what surface tension is, you see. So this is the formula for surface tension, okay? Some people will have F equal to 2L. Since 2 is a constant and a dimensionless quantity, just leave it like this. Yes. So that is it. So what's the dimension for force? What is the dimension for force? For you to get force, you can solve it to be, force is mass times acceleration. Mass is capital letter M. And then you say biblical physics. Acceleration, we know, is the change of velocity. Acceleration is change of velocity over time. And velocity over time will be Lt to the power of minus 2, right? So we have Lt to the power of minus 2. This is the way I used to derive my own, so that I will not make mistake. So we have mLt to the power of minus 2 divided by L. L will cancel L. Are we following? So surface tension, we have mt to the power of minus 2. Are we correct? Check if it is correct, please. Check if it is correct. All right. If it is correct, then let's plot it into this formula. For now, it's okay. You can neglect this K. I've told you that K is a dimensionless quantity. It doesn't have dimension. So let's plot in the value for this man, the density, which is this one. For density, we have ml to the power of minus 3 raised to the power of x. All right. And then we have for this one L to be arrow to be L raised to the power of y. And then we have for this, please, if you're just joining, like the video and share. If you have not subscribed to my channel, please hit the subscribe button. Please help me. Thank you very much. Okay, for the last one, we just did that, which is mt to the power of minus 2. And this is to the power of... oh, I'm seeing you liking the video. Thank you very much, and God bless you. I'm seeing you guys liking the video and subscribing. I appreciate you guys. Don't worry, I'm going to be with you till you finish. You graduate from this school. So make sure second semester you attend Instructor Allison tutorials, because we're going to be live teaching inside the school. And also watch my content always. It's for you. So what do we need to do? Keep in mind that this x is going to affect everything on the power. L is still the same thing. So we have this to be m to the power of x, L to the power of minus 3x. If you do not understand that, please ask question. I will tell you what happened there. And let me just tell you so that you don't ask me. If I have a, b, all raised to the power of k, just know that a will share with of this k and b will still share. So you have a to the power of k, b to the power of k. This will happen. All right? So they will share. So m is sharing of this x. L to the power of 3 is still sharing. That's why we have this. All that's clear. So we just keep y on top of this L. And then here too we do the same thing. M to the power of z, t to the power of minus 2z. Is it clear? So that's what we call comparing of coefficients. This comparing of coefficients is that we need to compare the left-hand side to the right-hand side. And then in this case, you notice that we only have t on both sides. But we don't have this on this left-hand side. So we just assume on the left-hand side we have m to the power of 0, L to the power of 0. Because in indices, anything raised to the power of 0 is 1. So 1 times 1 times t is still t. We are just bringing it because we have ml on the left, so we just need something that will correspond to it. It's not compulsory, but this to know that it's having power of 1. And this power of 1 is invisible. You can't see it with your aided eyes except to use microscope. True or false? All right. So let's do the comparing of coefficients. Let's start with this t. I'm having t to the power of 1 equal to t to the power of minus 2z. So you say it's false. It's only microscope you can use to see that 1 now. That 1 is invisible. I only brought it to visibility so that I can see it visually. Else, you can't see it except with the use of microscope. I'm telling you the truth. You're doubting me. All right, at this point, you can see that this t can cancel out according to initial expression. So you have 1 equal to minus 2z. All right, dividing both sides by minus 2 by minus 2. This minus 2 will cancel. Therefore, z is equal to minus 1 over 2. We've gotten the value for z. I'm not doing magic. I'm not a magician. All right, but you can ask question if you're lost at any point. Look at this L. I'm having double L here. I'm not comfortable with it. I just want them to be 1. And according to product law of indices, when the bases are the same, you can take one of the base and add the power. So I have minus 3x plus y. Is that correct? And this will be equal to this left-hand side. We have L to the power of 0. If you don't want to put L to the power of 0, just equate it to 0. It's still the same thing. This will cancel. So we have minus 3x plus y equal to 0. All right? Okay. So I'll just make this equation 1. Then let's work on m. M, we're having them to be 2. Take one of the m and add the power. This will be equal to m to the power of 0, which is this one. So at this point, we have this cancel out. And we have x plus z equal to 0. Equation 2. Don't mind those equations. It's not like they are going to distract us. Let me bring another slip. Okay. Are we following, please? Okay. So what do we do? From equation 2, I can just say that x is equal to, if I take z across, I'll have minus z. True or false? But remember that we have z already. We have the value of z to be minus 1 over 2. So it means that our x now will be equal to minus into minus 1 over 2. Minus times minus is what? Who can tell us? If you know the rule of sign, what is minus times minus? Good. Plus. So we have 1 over 2. If you're here and you've not liked this video and you've not subscribed to my channel, it's not a good way of encouraging me. You're not encouraging me. So if you're here, please just like and subscribe. All right, we've gotten our x already. With this x, we can get our y. So let's plug this x into equation 1. Equation 1 said minus 3x plus y equal to 0. So if you are meant to find y, we could just carry this minus 3x across. So we have y equal to 3x. Is that correct? So now y now will be equal to 3 times, what is your x? 1 over 2. So this will become 3 times 1 is 3 over 2. Therefore, x equal to 1 over 2, y equal to 3 over 2, and z equal to, what is z? Minus 1 over 2. Can we check the answer right now? This is what we've gotten. Can we check the answer right now? Ladies and gentlemen, let's go there. Let's check which option best fits what we are looking for. And let's go there. Question 52. That's question 52. Check the option. This is what we have. Please take note of it. X is equal to 1 over 2. Y is equal to 3 over 2. Z is equal to minus 1 over 2. And look at the option here. Question 52. Option A, we have 1. No, it's not part of it. B, we have, look at B. Look at B. Are you seeing B? Take note of this B. You're having 1 over 2, 3 over 2, minus 1 over 2. And look at it. 1 over 2, 3 over 2, minus 1 over 2. What if they repeat exactly this question tomorrow? How are you going to survive it? It means you just clear everything. But the thing is actually much, so it means you have a lot of things to look into. Let's solve 62. 62 has that kind of differential stuff. Those ones that are normal physics problem that you can do, like this question 48 that says, which of the following is correct expression of escape velocity? Of course, you should be familiar with escape velocity. So not those kind of problem. I just wish to work on this night. I just need to do. Oh, somebody said the time is the issue. My brother or my sister, whatever gender you are, the time is. Let me check so that I won't be predicting. Let me check the time that will be given to you. Are you seeing it? One and a half hour. But I bet you by the time you get up to 45 minutes, is assume you've already arrived 1.5 hours. So that means you shouldn't be looking at that time. You need to solve with speed and accuracy. Most of the thing you are going to do here is solving. So you just need speed. That's to be frank with you guys. I don't know which time is your exams. Otherwise, I would have loved to also come up by 4 a.m. to continue to make sure I solve all the stuffs here. Because after I solve this 62, I don't know if we still do more before I will leave. But I need to rest. I went for a concert to play music and then just came back and start solving these things for you guys. So I need to rest also. So 62, let's solve more problems. What time is your exam? What time is the exams tomorrow? Let's look at 62, question 62. Oh, your exams is 8 a.m. Oh, that's quite very early. I wish we knew about this. We would have done this stuff 2 days before today. But it's okay. Let's see how far we can go. 62 says the motion of a particle along. Anytime you see something that has to do with particle, be careful. It might involve differentiation and integration also. They say that the motion of a particle along a straight line is specified by the equation, this. I think they have already marked the. I don't know if I did that myself or. Well, let's see what happened. It's specified by the equation. Okay, this is the equation. Find the acceleration after 5 seconds. Okay. Let's fetch out the parameters. Okay, we have that x is equal to 4t to the power of 3 minus 2t squared. If you're joining us, you're welcome. Please like the video and subscribe to my channel. That will help me grow my channel. Somebody is asking, what year am I solving? I'm solving last year question paper. I don't think people have it. That's why I'm helping you guys in case if they bring question from here. Look at it now, 2020/2021. That's the one discipline in 200 level. This is the one that failed a lot of them. A lot of them are writing these exams with you. So this is a question, exactly this question. So you can see the A. All right. So we have that x is equal to this, and then we're asked to find the acceleration after. We are asked to find the acceleration after 5 seconds. Really, 2012? That is serious. All right, that means you need to marry the past question paper you have already. Joining this one, then you should be dangerous tomorrow. If I come around to invigilate, I will be happy to see you guys solving explicitly. Oh, thank you very much for those of you liking this video. I really appreciate it. Thank you for hitting the like button. Thank you for also hitting the subscribe button. That's actually helping my video on my YouTube channel to grow. God bless you. God bless you. If you've not done so, please just do that. Okay, for me to get the acceleration, this is x. X is just for distance. X is just for distance. So for you to get acceleration, it means that you need to look for your velocity, or to take the derivative of this twice. That's the simple way you need to do it in the exam. Instead of you to solve much, just say, for me to look for acceleration, I have to differentiate this thing 2 times. I will get acceleration. Then plot in 5, you get the answer. Is that clear? I'm telling you shortcuts. But if you want to do long cuts, you know that when you have the x over dt, the x over dt is the same thing as velocity. If I ask you to define velocity, you tell me that it's distance, the change of distance over time. Is it not true? So that means taking the derivative of this x, which is this one with respect to t, here we have 12t squared for this one, minus here we have 4t. So this is what I'm saying, that for acceleration, it means you have to take the second derivative, d squared x over dt squared. Or if you don't like this one, it's the same thing as saying dv over dt. The both of them are the same, meaning that you should differentiate this again. Differentiation of this will be 24t minus differentiation of 4t is 4. So at 5 seconds, Meaning that, oh, I'm seeing some people dropping the answer already. That is beautiful. It means you guys are super intelligent. Congratulations if that is the answer. Please, if you have calculator, let's work on this to see if what our brethren are posting is corresponding with what we are supposed to have. And if it does, that means you guys are dangerous already. It means you guys are dangerous already. The answer should be, oh, is that yours should be means you're not certain. Okay, somebody is posting 116. If it is 116, let's put it down. And what are we actually calculating? Is it for acceleration? Yes, acceleration is in meter per second square. Please, physics people value SI units. Maybe when you get to 200 level, take note of that. Make sure you fix it in your work. Okay, question 62. Question 62. We have... Okay, this is it. 116 meter per second squared. Congratulations, guys. You guys are super intelligent. Congratulations, my friends. You all are awesome. Oh, I wanted to leave, but let me solve some more problems because the way I'm looking at these things, the load is much on you. Let me see if I can add more problems. This is how it will look like. They will serve you like this. Everything will be attached, so there's no way you go with the question paper. Then you start flipping. So please, I want to guide you. This is important because last year I observed some persons are having issues. Some people were ticking here and then they did not reflect it here. Then some people did not tick here and they did all their work here. So when they submitted, this thing pull off. So this was not there. This was not there. So to give you your score was a difficult stuff. When you're writing your name, print it very bold on this and your maths number. Also print it on these ones. I'm just guiding you through so that it will help you. Write your names boldly and your maths number. Reflect it all if possible, so that if one is detached, the rest will be available for you. All right. So let's still see if we can solve some kind of technical problem. I'm seeing one here in question 11. I'm seeing question 11. Please take note of anything I'm telling you right now. Of course, you guys know that if you did not reflect your name across all those pages and one eventually pulls out, it's nobody's fault. Now somebody's saying I should solve T12 now. It's okay. Okay, you guys want to rest for tomorrow's exams? Oh, sorry. As at that 10 o'clock, I was editing the live video. I already put notification, but that was not working, so I had to cancel that and restart again. So maybe I started maybe 5 minutes after or thereabouts. So sorry. But this video is going to be intact. Maybe I may still upload it on my YouTube channel, but it's just that people may not have time to go through it. But I just wish you well in your exams. Let me solve more problems. More problems. Please look at that question 11. What is the answer? Go through question 11 for me. Go through question 11. And give me 1 second, please. Let me... Okay, are we together? So in that problem, we have the parameter. There are a lot of things given. We have the force given as 3 Newton, and the angle is given as 60 degrees. We're asked to find the work if the distance we have for 4 meters. All right, now from did you say I should show you this question again, the question that gave us this parameter? Is that what you're asking for? Look at the question, is question 11. They say a girl drags a bag of cement along okay. A girl drags a bag of cement along a smooth horizontal floor with a force of 3 Newton applied at an angle of 60 degrees to the floor. The work done after a distance of 4 meters is these options you're having. Okay, some persons have already started posting the answer 6 joules. Okay, let's go through it. So I have the parameter already that we have the force to be 3 Newton, and then the theta, the angle is 60 degrees. We have that the work is what we are looking for, and distance is 4 meters. So I'd like to let you know that by function of what we've read about the girl who was dragging a bag of cement along a smooth horizontal floor, that's talking about the effective component of the force along the horizontal. You've done the vertical component and horizontal component. Have you done something like that where you have something like this? You know that the vertical component, this is the vertical, this is the horizontal component. For horizontal component, you have something like u cos theta, and then for vertical, you have u sine theta. Have you done something like this? If it is a yes, if you've done something related to components, effective component of force along the horizontal, so then you can now say that for the effective component of force along the horizontal, that will be force cos 60 degrees, which is force cos theta. All right, then because you're looking for the work done by this force will be equal to force cos 60 degree x. This x here is talking about distance, which we have here to be d. Let me use d so that you'll not be confused. If you've done work, energy, and power, you would have been familiar with when an inclined plane, a body moving on an inclined plane, if she drags the bag like this on an inclined plane, this is the floor level, the ground level, and then it will make it will make an angle. This is the angle it makes on the floor, which is 60 degrees, and maybe it's a bag of mass. So on this kind of stuff, we have that the work done is equal to F cos theta D. Have you seen this formula before? If you have, then that's what I'm using. So it means that W at this point will be equal to, what do we have as this force? This force is 3 Newton. So we have 3 multiplied by cos 60 degrees times 4. 4 is for the distance. That means we have done everything here. So what exactly is cos 60? You need to know what cos 60 is all about. I told you I don't have calculator here. So if you have calculator, just punch quickly. What is cos 60? Let's multiply that by 3 and also multiply that answer by 4. And then let's see what the answer will be. From the Cartesian coordinates, the quadrant that this particular course falls in for 60 degrees is 0.5. Oh, somebody has dropped the answer already. I just do not want to use those figurative approach. That's why I need you to point your calculator. But it's okay. I'm seeing 0.5. Okay, what multiply everything? 3 times 0.5. This 0.5 is more like 1/2 times this, which is 2 times this is 6 joules. 6 joules. 6 joules. All right, let's check the options. Number 11. Sorry. If you're just joining, please like this video and subscribe to my channel. Thank you very much. Just hit like button. That thumbs up you have there, that is the like button. Just hit it for me, please. Hit it and subscribe. Hit it and subscribe. Hit it and subscribe. What's the option here? Do we have 6 at all? Okay, we have 6. Option C. Oh, congratulations, guys. You guys are super intelligent. I love this quad. I love this quad I'm having here. Check out number 14. Is that something you can be able to fix? Question 14. Question 14. Is this something you can fix? Question 14. What they say? The moment of inertia of a tine rod of length L and mass about an axis through one end is given by that one is simple. Moment of inertia. I don't know how far you're familiar with this aspect of physics, but moment of inertia L is 1/3 for a tine rod. We have moment of inertia for different materials, tine rods, steel, moment of inertia of a, depending, there are many. For tine rod, it's that particular formula. And here we have 1/3 over ml cubed. No, it can't be that. Half. No, it's not half. Oh yes, this is the option. This is the option. So B is the answer. B is the answer. B is the answer. C, number 16 looks like what we just did initially. Who can tell me the answer for number 16? The expression for the time taken for a projectile to reach maximum height. Oh, that is beautiful. What is the formula for, or the expression of, for the time taken for a projectile to reach maximum heights? If you're doing chemistry, it means when you're writing chemistry, we need to do online videos. I think I missed this for your mathematics. If I had known earlier, I would have done this for your mathematics, your physics, chemistry, and as the case may be. And you've written your stats, your statistics also. I think that's where I would have done these things to help you guys. But it's okay. I wish you guys well. Okay. Is somebody here with me? Are we together? Oh, congratulations. I saw, I'm seeing a response that mass was simple. Congratulations. Glory be to God. Okay, I'm waiting for your response. You've not done statistics. I thought stats goes with mathematics. Really? You've not done statistics? That means, I said, God help us for physics. He will heal. He will help you guys. He will. Number 12. Have we done number 12? I was showing you number 14. Was it number 14? Okay, let's look at number 12. Number 12 says, Statistics is next week. Okay. Please, if you subscribe to my channel, turn on the notification bell so that by the time I upload new video, you always get notified. I know I'm doing content from 400 level to 400 level student, but if you see content that belongs to you, that's meant for you, you'll be able to identify it. I think the last I've done video on the test for hypothesis, and then yes, I've done about 2 videos, one to explain it, the other one to solve one problem. And I had request of to teach how to check the Z table and the T table, which I will still do it for you guys. Okay, let's continue, please. When you subscribe, when you hit the subscribe button, turn on the notification bell. That will help you whenever I come live on any of these things. I'll let you guys know. Okay, for number 12, a rope is being used to pull a mass of 10 kg. So let's put it down. Mass equal to 10 kg. A rope is being used to pull a mass of 10 kg vertically upward. Vertically upward. Determine the tension. Okay, we are looking for tension. Determine the tension. All right. Determine the tension in the rope if starting from rest. Okay. The mass acquires a velocity of 4. Okay, we have velocity of 4 meters per second. Okay, so that is it. Okay, that's it. So the way you need to go about this is that we need the force needed to pull the mass of this 10 kg with acceleration A should have been V over T. That's the first approach. But V is given, T is not given. It's still given in this question. If T is not given, that means the question is not complete. If T is not given in this question, it means it is not complete. And when it is not complete, it can manipulate. This question is not complete. Number 12 is not complete. But for example, if maybe time was given, let's say time was given as maybe 8 seconds. I want to solve it maybe if they correct it this year and add time, because like this is not correct. If they add time, if they should add time, so what you should do at this point is just to say, are we following? Let it not be that I'm alone here. Are we following? If you are following, just type yes. Then I will know you're with me. Okay, beautiful. So we have here to be, it should have been 4 divided by 8. And this is more like, this into itself 0.5 meter per second, right? So if it's 0.5 meter per second, literal explanation of this is that if we have a mass of 10 kg, I need a force to pull it up like this, all right? And we have the acceleration to be 0.5 meter per second squared. I didn't add square here. Okay, squared. That means that the force now will be equal to the mass towards gravity plus mass times acceleration, and then this will be, of course, you know that this man is given as 9.8, right? 9.8. So you just use 10 multiplied by 9.8 plus mass is 10 multiplies by this particular one is 0.5. So if you do this, whatever you have to be the answer is your tension. because tension is also the same thing as force. All right, whatever I have, when you multiply this by this plus this by this, anything it gives you, you have it in Newton. The unit will be in Newton, and that will be the tension you're asked to find in that question. All right, please do it properly. You multiply 10 by 9.8. When you're done, multiply 10 by 0.5. Then add up the answer. Anything it gives you, that's the tension. I just hope you understand. But I'm not saying this is for the question we are solving, because this 8, I'm the one that just fixed it if the time we are given, because of course, you know, you have to find acceleration at this point. So since the time is not given, there's no way we can find acceleration. That means the question is not complete. So let's not dwell much on question 12 that is not complete. Let's move straight up to, I think, okay, you can see the nature of the answer now. From what you get, see the nature of the answer. What number was that? You're seeing 100 Newton. You're seeing 195 Newton. All right? You're seeing 75 Newton. You're seeing 95 Newton. That's because time is not given. If they have given a corresponding time, we would have gotten one of these options. That's how you can get your tension. But I hope you got the flow. In case of necessity, when you're given the time, you should be able to. I hope you got the flow. If you have, then let's continue. If you got the flow, let's look at number 13. Are we here? People are going to bed gradually. I think I'm having 33 persons or 38 persons still here. But if you're just joining, please don't forget to subscribe to my channel and like this video. Let's see number 13. Is that what you can be able to do? What is the property of a fluid that defines the resistance to shear stress? What is the property of a fluid that defines the resistance? What is the property of the fluid? I think that's viscosity. That should be the viscosity. They say you should find the property. They say you should find the property of a fluid that defines its resistance to shear stress. One, they say dynamic pressure. And no, we have thermal conductivity, no viscosity, because viscosity talks about the internal friction that exists between layers of fluids. All right, so the answer is C. That's not two ways. I think I'm seeing somebody typing C. Correct. Have we done number 14? Yes, we've done number 14. I think we said this number B is the answer to number 14. Okay. I need to go right now. Number 16, 17. I asked you people to do this number 16 because we've tried something related to this. Number 16 and number 17. It's simple. It's something you can do. Which of the following helps to determine the volume of irregular shape? Volume of irregular shape. That's Archimedes' principle. Density, law of capillarity, viscosity. Archimedes' principle. Because for you to determine the volume of irregular shape, let's say the shape we want to talk about is a sphere. A sphere, all those small round ball. They call it sphere, like shot put. If you're secondary school, you will use shot put. That thing that is very heavy. You know javelin, you know shot put and all those things. Okay, so by the time you drop that small sphere in a liquid, just put a liquid in a cylinder and put the sphere. You notice that the volume of the liquid will rise. So you have to subtract the initial volume from the final volume. And one principle that does that is Archimedes' principle. Archimedes' principle, when a body is partially or fully immersed in the water. Do you know this principle? When you press a ball in the water, that's partially. whether it is partially or fully, you know that the water volume will increase from the initial one. So that is Archimedes' principle. The answer to this problem is C. Are we following me, or am I alone here? These people are tired. Let's go. Let's go. Yeah, somebody is responding to me. It experiences an upthrust. Yeah. You guys will blow this exam. So somebody is responding to me. I think equal to the amount of liquid. Okay, I didn't get what you typed, but you're on point. You understand? So I'm not alone here. I'm not alone. Oh shit, my battery is down. See why I don't like using iPhone. And I did not charge this Android. Shit. What are we gonna do right now? What am I gonna do? This battery is down. Yes, equal to the liquid displaced. If you do that practically, that is correct. If you do it practically, it is correct. Okay. So I will oblige you guys to chat me since we don't have much time any longer. The rest of the questions are simple. Like this 62 says, is that 62 or 65? What is the rest? I'm just trying to let you know that you need to come on WhatsApp so that you have the copy of it. 65 say, what is the dimension of density? Is it not what we just did? So guys, what is the answer for this? They say, what is the dimension for density? We just use it to solve problem. I think you've seen it right now. Somebody should talk to me. I think you should have seen it right now. What option is that? Somebody is suggesting if we should come back by 4. Is that okay? Look at. This is why I just need to go. Look at number 69. 69 is saying, okay, if you don't have my WhatsApp number, I don't know if I can drop it here so that you can chat me up and introduce yourself. Then you have the paper. 69 said, which of the following is a scalar quantity? You know, of course, scalar quantity has magnitude but no direction. So force is a vector quantity. Weight, mass and acceleration is a vector quantity. Displacement is a vector quantity. It's distance that is a scalar quantity. Altitude is talking about height. Altitude is a scalar quantity. Are you not seeing how cheap these questions are? So it means you can finish them. Trust me. Then I say 61 says, which of the following are derived quantity? Derived. Okay. I, of course, is not a derived quantity. I is a derived quantity. Newton. Kilogram is not a derived quantity. IV, ampere, is not a derived quantity. Joules is a derived quantity. So that means we have II and V. So what is the option? II and V. What is the option? II and V. II and V. Have you seen the option already? II and V. Good, you see. Good. So you can see the questions are fair. I'm not even talking about this other part. What is happening? I'm not talking about this other part. Okay, so what should we do, ladies and gentlemen? I just have to go. I didn't know I would stay this long. Somebody said I should stay till 12, and this is already 12. And my phone is about to go off. I need to power it. So what should we do? Okay, you've not taken my number 070. Oh, I don't wish to drop my number on this page. You could just, somebody is even typing. Okay, I think I left my number on TikTok. Just type instructor Allison. This is how you type it. After you type instructor, then you see this, I don't know what they call it. It's not like iPhone or those one that is down. So you have instructor, or in small letter, instructor. Then this one down like this. What do they call it? Underscore. God bless you. I have 2 accounts. Then you have Allison. So when you write instructor, double underscore Allison. That's my second TikTok account. The first TikTok account is just 1 underscore. That's not the one I want you to chat me. So when you add me there, just chat me privately. I will respond to you back. Yes, just chat me up. I will respond to you there, because I also teach on that platform. And if you navigate, you see my number there too. Chat me privately on WhatsApp. I will respond to you. Thank you very much for participating on tonight's tutorial. I so much appreciate you guys. I wish you success in your exams. And then I will see you when I see you. If you have questions, please ask before I will leave. If you have questions to ask, if you have questions you wish to ask, please do ask. Let me respond to your questions. Okay, somebody is asking how many types. You usually have type A down to F. Yes, type A to F. This one I'm using now is type D. So you have a lot of types tomorrow, a bit today. You have a lot of types. So why it is important for those of you who are still remaining here watching and listening to me, why it's important to subscribe and turn on the notification is because I'll still come on live for your statistics. I'll still come on live for your chemistry. That's if 400 levels students or 300 or 200 have not engaged me already on their physics and mathematics. I'll be right there for you guys. So just make sure you hit the subscribe button, turn on the notification bell, and make sure you follow me up on WhatsApp too. I have groups that I have created for second semester tutorials. Make sure you join us and then enjoy more of electricity and magnetism and the fields of heat energy. We give you back to back. More questions, please, because I'm about to leave. Yes, somebody is saying A to F. Yes, we have type A, type B, type C, type D, type E, type F. Yes, we have a lot of types. My departments are wonderful. Why don't you want to drop your number here? Oh, I don't usually do that when I'm on live stream. Oh, but okay. 07039618664. Somebody's asking if I'm going to come by 4 a.m. I'll only come by 4 a.m. if I will see people that will teach by 4 a.m. And if I accept to come by 4 a.m., then you should allow me to go by now so I can be able to rest my head. But the point is that I do not want to disappoint you guys. That's why I wanted to also give you guys this thing to go through them. What if they just repeat exactly this tomorrow? It's 12 o'clock already, so what if they just repeat exactly today? That's the more reason why you need to do more practice. Am I skipping any question already? Okay, past question for this year. They have not written exams already. If they have written the exams, definitely I will have the past question. I'm doing my master's degree in physics department, in theoretical and mathematical physics. So I'm active. What question? Good night. Okay, thank you very much. Thank you very much. Thank you very much, guys. Okay, for last year, that's why I say people should chat me up on WhatsApp or check my TikTok. You see my WhatsApp number. I've also called 07039618664. That's my WhatsApp number. Any further question? Adson is asking if you should message me. You could just message me. If I see the message, I will respond to you. If I didn't see it early, you don't need to get offended. But when I see it, I will respond to you. So thank you very much for joining me. I will see you when I see you. Bye-bye. Good night. Good night.